If you are an automotive engineer in India today, listen to this for 15 seconds. You are probably earning between 8 and 15 lakhs a year. The exact same experience, but at Qualcomm, Nvidia, or Intel pays you 18 to 40 lakhs a year, sometime even more. So the skills are 80% the same, but thousands of automotive engineers try to make this switch every year and most of them fail. Why? Because they don't know what semiconductor companies actually test in interviews. In this video, I am going to give you the full 6 month roadmap to switch from automotive to embedded and semiconductor companies in 2026, step by step. So stay till the end. I will also show you exactly which semiconductor companies to target, what they ask in interviews, and how to write a resume that get shortlisted. Hi, this is Rahul Mehta from Embedded Shiksha. I have helped over thousands of engineers cracking interviews at top semiconductor companies in the last three batches of our bootcamp. And first, one type of student we get is automotive engineers, people stuck in AutoSAR configuration jobs who wants to do real low level work. So the roadmap is built from real students' data, what worked and what didn't. So let's start. So first of all, why automotive engineers are perfectly positioned? The semiconductor industry is booming in 2026. AI chips, edge computing, ADAS, IoT. Every product needs more silicon, and companies like Qualcomm, Nvidia, NXP, TI, Intel, MediaTek, and Broadcom are hiring aggressively. So here's the good news for you. As an automotive engineer, you already have 70% of what they want. You just don't know it. Most of you think your AutoSAR job is a problem. It is not. Your hardware closeness is your superpower. You just need to repackage it the right way. So let me show you what I mean. You already have four big strengths that semiconductor company pay top money for. So number one, hardware software integration. You understand registers, peripherals, and timing. This is exactly what chip companies need on day one. Number two, protocol knowledge, CAN, SPI, I2C, LIN, UART. These are tested in every single embedded system interviews. You already know them. Number three, safety and MISRA-C, ISO 26262 and ASIL experience is rare and valuable. It's gold for medical, aerospace, and ADAS chip teams. Number four, real-time thinking, deadlines, watchdogs, interrupt priorities. This mindset is central to semiconductor work. So please don't say I am an automotive guy. You are not. You are a low-level embedded engineer who happen to work in cars. That framing matters. So now the bad news, you also have gaps, and these are the exact gaps that make people fail interview. Gap number one, deep C programming. Pointer arithmetic, function pointers, memory layout, bitwise operation, volatile and constant, register manipulation. AutoSAR config tools will not prepare you for this. You need to write C code from the scratch. Gap number two, bare metal register level programming. Can you set up GIO by writing directly to a register without using any HAL library? Can you configure UART by reading the reference manual? If not, this is the gap number one to fix. Gap number three, RTOS internal. Just calling X task create is not enough. They will ask you about scheduler, context switches, priority inversion. You need to know how the RTOS actually works inside. Gap number four, Linux kernel. So this is for SoC companies, Qualcomm, Nvidia, Intel, kernel module, device tree, device driver architecture, DMA. They expect this from day one. Gap number five is data structure and algorithm. Linked list, tree, hash table sorting, but implemented in C, not in C++ STL. So this is the round most automotive engineers fail. So five gaps. Don't get scared. I will tell you exactly how to close them. Before anything else, C is mandatory. There is no shortcut, no alternative. Every semiconductor company will test your C skills in depth. So here are four things to master. Number one, pointer, pointer to pointer, function pointer, void pointer, array versus pointer. You should be able to draw memory diagram in your head. Number second, memory layout, stack, heap, BSS, data, text segment, structure padding, alignment, independence, everything you need. Bit manipulation, set clear toggle bit fields, creating bit mask, register manipulation patterns. From hardware interaction, why we use volatile, when to use const, mimoxs, read modify write pattern. So here is my test for you. Can you write a GPIO driver, a UART driver, or a timer interrupt handler completely from scratch using only the chip reference manual? No HAL, no ID wizard, or no stack overflow. If yes, then you are ready. If no, then that is your first 6 week of work. Now comes a big decision. You have to pick one path to go deep in. Don't try both at the start. You will end up shallow in both. Part A, RTOS. This is best for MCU products, IoT, wearables, medical devices, industrial controllers, ADAS ECUs. Learn free RTOS first. It is the most popular. Then Jaifer, master task, scheduling, semaphore, mutex, queue, ISR notification, memory pools, and then timers. Path B is Linux kernel. This is the best for big semiconductor companies: Qualcomm, Nvidia, Intel, MediaTek, Broadcom, Samsung. Master kernel modules, character drivers, platform drivers, device tree, interrupts, kmalog, DMA, spin log, power management, debugging with print K and ftrace. So my honest advice is, if your dream is Qualcomm, Nvidia or Intel, go for Linux. If you love MCUs and want NXP, TI or microchip, go for RTOS. Pick one, go deep, then learn the other later. Many top engineers know both, but for into prep, depth wins. Okay, so if you want to choose any of this path, RTOS or Linux kernel, you can reach out to us, you can ping us. We have the program going on for both RTOS as well as for the Linux. So this batch we have designed considering the automotive people. Basically, we understand their background, and we have basically created a complete roadmap for them, starting from C programming, then going into the RTOS or Linux kernel, and then switching to the actual into prep. Right now, let's talk about 6 month roadmap, basically career switch roadmap. So now the actual plan, you can do this while keeping your current job, 2 to 3 hours a day on weekdays, 4 to 5 hours on weekend. That's it. So month 1 and 2, C and bare metal, master pointers, structure, bitwise operations, solve 50 pointers problem minimum. Then move to register level programming on STM32 or TI boards. Configure GPIO UART timer interrupt using only the reference manual. Month 3, pick your path. If RTOS, free RTOS and STM32. Build a multitask sensor system with mutex, queues, ISR notification. If Linux, set up the kernel dev environment, write your first module, build a character driver, then a platform driver, learn device tree overlays. Month 4, build 2 3 real projects. So this is the most important month. Pick projects that show off what you learned. Some good ones: an I2C or SPI sensor driver, a multitask RTOS app integrating two protocols, or a Linux platform driver for a custom peripherals. Push everything to GitHub with clean README files. So this is your portfolio. Month 5, DSA and system design. Implement linked list, stack, queues, hash table and trees in C. Solve 50 plus lead code, easy to medium problems in C only. Then study boot sequence, memory maps, and how peripheral subsystem are designed. Month 6, into prep and apply. Do mock interviews, rebuild your resume around your projects, apply through LinkedIn, Naukri, company career page, and most importantly, referrals get you 5x more callbacks. So that is a full plan, 6 month doable with you while you keep earning. Quick rapid fire on what each top company actually looks for. Qualcomm will look out for deep C, Linux kernel, device tree, power management, ARM architecture roles, kernel engineers, BSP engineers. Nvidia will focus on C and C++, Linux drivers, basics of CUDA architecture, GPU architecture, debugging roles, system software driver developers. NXP is going to focus upon embedded C, RTOS, free RTOS or Jaifer RTOS, ARM, Cortex M and R. Automotive protocols roles will be firmware engineer, MCU applications. Texas Instrument is going to check your bare metal and RTOS, communication protocols, analog and mixed signal basics. Role will be embedded software or SDK developer. In Intel, They will ask you C, x86 architecture, low level firmware, Linux kernel, platform hit, and the roles will be BIOS, UEFI, kernel engineers. And then MediaTek and Broadcom, Linux drivers, Android HAL, connectivity stacks, SoC bring up, role will be device developer or BSP. Pick the one that excites you and prepare specifically for them. Don't shotgun everywhere. The interview is usually 5 rounds in all of these companies, most of the companies. The round one will be online coding, 2 to 3 C programming questions on hacker rank, pointers, bitwise, string, data structure. Practice in C only, not C++. Right? Round two will be Round two will be your C and fundamentals, output prediction, memory layout, undefined behavior, plus OS basics, cache, pipeline, MMIO. Round three will be domain specific. If you said RTOS, expect scheduling, priority inversion, deadlock, ISR handling. If Linux, expect kernel modules, driver lifecycle, device tree, DMA synchronization. Round 4 is system design. Design an I2C driver from scratch. Explain ARM SoC boot sequence. Architect a multi-sensor data acquisition system. Round 5 will be managerial and HR. Why are you switching from automotive? Frame it positively. Talk about growth, your love for low level systems, your project. Never speak negatively about your current company. Right? Now let's talk about resume tips for the people who is preparing to switch in next 4 to 6 months. So your resume needs to tell one clear story. I am an embedded system engineer with automotive experience who has independently my skills, deepened my skill in RTOS and Linux kernel development. Highlight it loudly. C programming expertise, pointer, bit manipulation, MMIO, bare metal and register level work, protocol, CAN, SPI, I2C, UART. You all know that. Personal projects with GitHub links, debugging JTAG, logical analyzer, oscilloscope. Okay. Downplay or remove AutoSAR configuration tool work. Recruiters skip this. Testing only or validation only roles. Generic lines like supported customers. Right? So create a project section right after your summary. Lead with what you built, not where you worked. Recruiters spend 10 seconds, make those 10 seconds count. Okay, so that is the full roadmap. 6 months, five gap areas, three projects, one clear depth. Now, I want to be honest with you for a second. Most people who watch a video like this will close YouTube, feel motivated for 2 days, and then get pulled back into deadlines, bugs, and the same daily grind. 6 months passes, nothing changes. If that is you and you know who you are, this is a faster, structured way. We have just opened Bootcamp 4.0, the embedded system into prep bootcamp. This is the same roadmap I just showed you, but compressed into 8 weeks of live mentorship, not 6 months of self doubt. So here's what is inside: advanced C for embedded, pointers, memory, MMIO, RTOS internal and real-time system design, Linux kernel and drivers, embedded system designs, resume building, and one mock interview. And then there will be doubt clearing sessions every week. So past three batches, over 1,000 students placed at top semiconductor companies with 92% success rate. The next batch starts on 4th of May. The price is 9,999. That is less than what most of you pay for 1 month of EMI on a phone. Seats are limited because we keep batches small for proper mentorship. Link is in the description and pinned in the top comment. Click, read the full curriculum and decide for yourself. If this video helped you, like it, subscribe, and turn on the bell. I post weekly videos on embedded system, kernel debugging, and interview tips. I will see you inside the bootcamp or in the next video. Until then, start your month one today with one pointer problem. That is the only thing that matters. Take care.